G'day comrade subscribers. So, after all the excitement of our little Slovakian friend, we're back to this Belarusian specky clone. Continue chipping away at it until we get the damn thing to work. Of course, we could probably just rip this board out but put a new one in. So, where we were at is basically looking at the clock. The clock signal looks pretty dodgy. So blah blah blah. Just as a reminder, so the clock is so we've got the crystal there at some weird 13.8 blah 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 megahertz. So we've got a couple of 3 inverters, then going into 2 flip-flops. So we've got 3 inverters, I guess, to shape the signal. Then the first flip-flop halves it, so we get 7 megahertz system clock, I guess. And then we go through another flip-flop, halve it again to get 3.4 something, which actually is the RAS signal as well. So that's where the clock is generated on this one. So on the board itself, we have the crystal here, and then we have the inverter gates here, and we have the D-type flip-flops here. So we'll have another look at the signal coming out of there into the Z80 here. And before I go pulling anything else out of the board, we've got a special guest appearance, the Parus VI-201. So this fellow comes out of Sevastopol in Crimea, so it's a Ukrainian clone. The reason why I've got it, I've made one video on this one. I couldn't get video working out of it, but it was working because you could hear the little tap 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 of the key presses. It's, as you can see, it's a beautiful machine, and you can actually detach the keyboard. So look at all those beautiful green, the K1M capacitors. Beautiful. So yeah, so the reason why I've got this is that it's pretty much, you can see that it's all discrete logic. There's no ULA, so the clock is generated in a pretty much a similar fashion. Where's the schematic? So let me just put this to the side. Might actually detach the keyboard, might do that. So I need to get back to that one actually to get the video working. But you can see here we've pretty much got a similar thing. We've got the crystal and a capacitor, and we run it through 3 inverters, and then we go off to this KT1, which I couldn't find. I couldn't find the KT1, but I'm assuming it's somewhere close. But I thought we could compare the signal between that one and this one, just to see if we've got a similar kind of input here. So I'm assuming the inverters kind of shape the signal. On the Kvant, yeah, we're not getting 5 volt. We're not getting a 5 volt TTL signal. We're getting it's 4 volts or 3.8 volts. So yeah, so let's get all that set up and check it out. All right, let's see how we go. So that's yellow is the Kvant. That's the clock pin 6 on the Z80, and the blue's going to be the Parus, or the sail. Clock's pin 6 as well, clock. So I'm going to try and do this two-handed. So 1, 2, 3, 4, 5, 6. All right, so blue is that. That looks very stable, doesn't it? So yeah, blue is the sail. So it's not like a pulse, like a nice square pulse. So, but why does it jump around so much? 1, 2, 3, 4, 5, 6. Yeah, just see how stable it is. I'll press. Let's see if I can press auto. All right, okay, so that's more stable when I just do Set it on auto. Okay. So it's 4 volts. Okay. If we activate channel 2. 1, 2, 3, 4, 5, 6. Okay, right now okay. So don't prove nothing. Alright, okay. So 1, 2, 3, 4, 5, 6. Alright, so they're pretty much both the same then. I don't really see any difference between the clocks there. So maybe the clock's okay. Okay. Let me have a think. Alright, let's just compare, just before we go off the clock. So this is the sail, the Parus. So we're looking at voltage peak to peak, about 4.2 volts. So it's slightly higher. 4.2 volts, 4.3 volts. Okay. Now, if we re-enable channel 1, and we have a look at the Kvant, or the quantum again, clock, pin into the Z80, 1, 2, 3, 4, 5, 6. So let's go auto. So it is slightly I got some signal on the screen. So it's 4 volts. So I don't know what I'll just have a look at the Z80 data sheet just to see what, if there is a minimum cutoff for the clock voltage. But I did get a little bit of garbage just appeared on the screen. Because I've got the video connected up, and a little bit of garbage did just appear. So the only difference I can really say, apart from the difference in frequency, is that the Kavant's peak-to-peak voltage is 0.2, 200 millivolts less. All right. All right. I'm still coming back to this clock. So I had a look. The spec for the clock, so the high voltage has got to be a minimum of VCC minus 0.45. So VCC technically is 5 volts, but let's, where's 5 volts on the Z80? 5 volts on the Z80 is pin 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that right? Or should I just use a normal voltmeter? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, okay, so that's 5 volts basically, isn't it? So 2 volts per division, so it's about 5 volts. What's this? 4.8. 4.8. All right, so say it's 4.8, the mean. Let me just double check. I'll do it on the voltmeter as well. Oops. Right, it's VCC minus 0.6. So that means I was getting 4.8, wasn't I? So where was it? I think it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4.8, so say 4.28, so 4.3 is the minimum the high voltage on the clock should be. All right, remember that. 4.3, say, 4.3 volts. All right, let's check the clock again. Okay, let's check the clock again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. 4 volts. That's not enough. It's got to be 4.3. Don't it? And it even collapses under that. So one thing I can see is that if you're using NMOS, which we are, I believe, there should be a pull-up 330 ohm pull-up resistor on the clock line to bring it up. So that's out of spec. Yeah, that's too low, isn't it? So even though the shape looks the same as on the Parus, it's just we're just not hitting the right voltage, are we? So let me have a look. So one of the things I like to do on my channel is give you guys a real good 4K close-up of the board. Let me unplug this. So, which I've normally done handheld, but that can be a bit iffy. So this is, let me unplug that. So the problem is this one is the keyboard's still connected. There's no, okay, maybe I can do it like that. Okay. So I'm going to set, so over here, oh, now the screen's in the way. Get the screen out of the way. All right, now maybe I can show you guys. A bit more light. Okay, so as I've been going on and on and on, okay, there's the crystal. There's our inverters. There's our flip-flops. And I think over here, this is on the clock circuit. So we've got a capacitor and a resistor just before we go into the clock circuit. So we might already have a pull-up. So I'm going to double check that. You can see it's not really in the schematic. It doesn't show these. So I'm going to double check that. But I'm pretty sure that this is, well, if I get my poker, I think that there is the clock circuit. But yeah, certainly the documentation seems to recommend a pull-up. So maybe the issue is it's not pulling up enough. Right, so yep, I buzzed it out, and that's definitely the pull-up, that green one there. And have a look. It seems to say 1K, 2K, so I'm not exactly sure. But the southern pin, that goes to the clock, and the northern pin, also where the capacitor is connected, that goes to plus 5 volts. Well, it goes to VCC, and then we've got the capacitor going to ground. So it should be pulling up. So I come back to this again. Do I replace the flip-flop that's outputting the signal? Don't know. What do you reckon, guys? I might make this a short one. So let me know what you think. Shall I pull this one out? So that's a 7474. So I can replace that. That's a hex inverter. Or do I replace this? So let me actually check I might check if I can check the resistance. So I think it says 330 ohms in the Z80 documentation. It's just under 1 kilo ohm. So I guess maybe it's a 1K resistor. So should I reduce it? Maybe. I don't want to do unnecessary soldering because it is quite easy to damage the board. All right, I'll leave it there. Let me know, and I'm going to have a look at something else. Maybe the Parus, I don't know. Let's maybe dig something out that I haven't touched for a while. Okay, bye for now.